All right, gang, we're just going to move right on into the next section that deals with factoring. So we're fully committing here to all this factoring stuff. This is going to be a little bit of a process. You know, this whole thing, this whole world of factoring, just gets a little more and more fleshed out. So, um, in other words, last section we learned only the first method of factoring. We learned how you could like find a GCF from all the terms and factor it out in front. So a couple quick examples that have to do with the previous section right here. 12x squared minus 6x plus 15. So again, I'm going to be repeating this probably a bit. The first method that we learned, and it's the first method you should always try, is a GCF. So 12x squared, 6x, and 15. Is there a GCF? I think there is. You know, the biggest factor for all three of these terms is 3. It's not very big, but all of these terms have a factor of 3. They don't all have an x. This term does not have an x. So, you know, we don't have an x in our greatest common factor. All these terms don't have an x in common. So the most we can bring out from all the terms is 3. And then you basically divide it out. You undistribute. So you put whatever's left over from the 3 terms in this bubble right here. So we got 4x squared minus 2x plus 5. Okay, because when you divide a 3 away from all 3 of these terms, this is what you're left with. In other words, 3 times all of this gets you back to the original problem. This other example, it turns out that, okay, the 4 and the 10, the GCF is really just 2, but then you notice that they both have x. They both have x's. This is x squared, this is x to the first. And remember, you always go with like the smaller of the powers, you know, for variables and stuff like that. So x to the second, x to the first. You can bring out x to the first. And so what's left over here is 2x plus 5, I believe. So that was just another couple of examples of the method that we looked at last section, in section 2.11. But now let's look at this example. So now let's get into this some new stuff. Look at this example. Factor this trinomial. Okay, it's a whatever polynomial, but it's got 3 terms. So that's why I'm calling it a trinomial. But let's try to factor it. Is there a GCF? Well, no. You got all of the terms don't have an x. This last term, so they all don't have an x in common, or any factors of x. And between like 1, because technically there's a 1 out in front, and 15 and 36, the GCF is really just 1, which doesn't really count. Like, can you imagine factoring out a GCF of just 1? What would that even do? Like, nothing. So a GCF of 1 doesn't really count. So in other words, it doesn't have a GCF. So, but how can we factor this? Okay, well, let's remember that factoring in general is breaking it up into like something times something. You're breaking it up into like an overall multiplication problem. Like this right here gets broken up into like this 3 times this bubble. Factoring this essentially broke it up into this term of a 2x, or this monomial of a 2x, times this bubble, you know, which is a binomial. So in other words, a monomial times a binomial. You know, factoring is breaking it up into like a multiplication problem. Well, it turns out that this trinomial is, I totally, I took a risk and I think I'm wrong. 36. It should have been this. Sorry about that if you were started writing fast. So it turns out that this trinomial is this bubble times this bubble. Okay? And that's another form of factoring, because again, we've broken it up into something times something. Okay? And you might be wondering, well, how did I get that? Like, how did I do? I mean, I made a mistake at first, you know, because I didn't really think to check if I was right. I just started writing something. But you know, I did sort of do this kind of fast. Like, how did I figure out that, you know, these two bubbles multiplied to get that? Well, let's look into that a little bit. The second method of factoring, a lot of people call unfoil. A lot of textbooks, a lot of math teachers across the country are going to refer to it as unfoil. Kind of like this, I've been sort of referring to here and there as like undistributing, like the basic distributive property in reverse. This is like that FOIL multiplication in reverse. So I want you to notice something. Now this is going to be like back to multiplying, like back to FOIL. Let's say it was like x plus 4 times x plus 5, and we FOILed this together. We multiplied it by doing all this extra distributing that needs to happen. So the firsts, the outers multiply, the inners, the I in FOIL, and then the lasts. Okay? Now, obviously, this isn't done until I combine these like terms here in the middle, and I get 9x. Okay? So, maybe you've already noticed, or you've just noticed, or you've already known this for months or years. Look at what happens when you FOIL bubbles like this together. If that's just x, and that's just x, of course you're going to have an x squared in this final answer. And also, if that was just x and that was just x, you're just going to have a couple terms here that add up, and this 9 is literally 4 plus 5. Positive 4 and positive 5 combined, like added. And this plus 20, where'd this plus 20 come from? Oh, obviously from this positive 4 being multiplied to this positive 5. This is a very, very like useful thing to notice, because turn the page. When we go to now unfoil, we can like reverse engineer that. So since this is just an x squared, you know, and first of all, maybe I need to be thorough here. First of all, you try for a GCF. But spoiler alert, none of these examples, none of these 8 examples are going to have a GCF other than 1, which doesn't count. See, like the GCF of all 3 of these terms would be 1, which doesn't count when we're factoring usually, okay? So I notice, so again, now my plan B is unfoil. Unfoil again means I'm going to break it up into like a binomial bubble times a binomial bubble. And if that's just x squared, then my bubbles are going to pretty much have to start with x and x. And if that's the case, I can play this really straightforward game of what 2 numbers multiply to become positive 30, but at the same time, they add up to positive 13. Now again, okay, elephant in the room, at least a baby elephant in the room. if you are really good with your times tables, if you're stronger than the average bear with, like, your mental math, you're going to find this, easier than other people. But if you struggle with your mental math, if you're not very good with your times tables, you might literally have to go up here and write all the different ways to have a couple numbers multiply to become positive 30. Like 1 times 30, But does 1 times, okay, 1 and 30 does make 30 here. But do they add up to become positive 13? No. So then we check 2 times 15. That gets me 30, but does that also add up to 13? No, that adds up to 17. So then I move on to like 3 and 10. Bingo. 3 times 10 is 30. 3 plus 10 is 13. So all I do now is put positive 3 and positive 10 in those bubbles, and I'm done. I've successfully unfoiled this and figured out the two bubbles that would foil together to do that. And therefore, that's factoring. Okay? Because now it's something. All right, here we go. Now we can sort of do the rest of these examples fairly more quickly, Again, no GCF other than 1, which doesn't count. So I check to see if there are two numbers that multiply to get positive 8, but they also add up to positive 9. See, again, like, you might already know this if you're pretty strong with your mental math. Some of you might be a little stumped, and you might have to, like, literally go up here and do, okay, 1 and 8, 2 and 4. Those are the only ways to get 8, with nice numbers to multiply to get 8. So do any of these pairs also add up to, yeah, positive 1 and positive 8. And by the way, I don't think I need to say this too many times. It doesn't matter which one you put where. Like, you could have put the plus 8 here. It doesn't matter, and the plus 1 there. But it's positive 1 and positive 8. Number 3. There's no GCF. If there was a GCF, I would have done that method. But x squared just means the bubbles have to start with x and x, and then we get to play this really easy game of what two numbers multiply to become positive 12, but they add up to negative 8. Negative 8? Yeah, that can happen. That can happen. Think about it. What two numbers multiply to become positive 12, but they add up to negative 8? Remember, people, positive 1 and positive 12, of course, get the job done, but so does negative 1 and negative 12. Remember, a negative times a negative is positive. But does negative 1 and negative 12 add up to negative 8? No, it adds up to negative 13. So let's move on to like negative 2 and negative 6. That gets me positive 12. And it also gets me negative 8. There we go. So that's that answer. Done. That's been factored. This next one. So the signs matter. The sign, again, like here, the sign, so we're going to multiply to become a positive 21, but add up to become a negative 10. See, I have a lot of experience. I know that's got to be a negative and a negative. It's the only way to get a positive here and a negative here when we multiply here but add here. So think about it. What two numbers multiply to become positive 21? So think about all the ways you can multiply a couple numbers to get 21. There's not that many, but they also have to combine to become negative 10. Feel free to pause the video. Like, I encourage you, like, pause the video and see if you can figure this out. Like, maybe you got to use your calculator. Maybe you got to write it up here, all the different choices to pick from. But, I'm going to give the answer in about 3 seconds, so. 2, 1. Should be negative 7 and negative 3. That's what gets it done. And again, if you were to FOIL this back together, you would get x squared minus 10x plus 21. Number 5. Okay. I'll do this one with you, and then I might want you to try 6, 7, and 8 on your own. But so here we go. Number 5. Once again, there is no GCF, because a GCF of just 1 doesn't really count. Okay, well, most of the time with factoring. So there's no GCF, so we move on to, well, maybe this can unfoil. Maybe we can make it into like a binomial times a binomial. And again, I know I keep repeating this, but it's important. I want to drill this into your brain. I want to sear it in there. If that's just an x squared, first of all, you're thinking, yes, that's just an x squared. You'll see why like tomorrow. But that just means it's going to be x and x. And we can play this real easy game of like, how can you multiply to get a oh my gosh, this is new, a negative 18. How do we multiply to get a negative 18? Don't the signs have to be different? Yeah, they got to be different. So we could have a positive 1 and a negative 18. That's my first possibility. But does positive 1, and again, the sign's got to be different. Remember, that's a negative 18 now. But does a positive 1 and a negative 18 combine, like add up to a positive 3? No. These add up to a negative 17. So nope. Well, how about a negative 1 and a positive 18? No. I mean, that is another possibility, to get negative 18. But this will just get you a positive 17 so no, that's not positive 3, it's positive 17. So we move on to like maybe positive 2 and negative 9. Positive 2 and a negative 9. That gets me the negative 18, but does that get me a positive 3 when you add them up? No, it gets me a negative 7. It gets me a negative 7. Okay? So now, and even like the negative, even if I made it a negative 2 and a positive 9, that would just give me a positive 7. So, oh my gosh, what's next? How about a positive 3 and a negative 6? That gets me positive 18. But what does that get me when you, oh my gosh, it gets me a negative 3. Oh, so close. So close. You see that? This gets me, when you add these up, it's negative 3. Oh my gosh, you're telling me like, I think literally on my last guess. So it's got to be a negative 3 and a positive 6. Because again, it's got to make a positive 3 when you add them up. So that 6 has to be the positive 1. So it's a positive 6 and a negative 3. Booyah. Okay. I encourage you now to pause the video. See, 6, 7, and 8, there's not going to be anything like super new. Not super new. So I encourage you to pause the video now and try 6, 7, and 8 on your own. And then when you unpause it, I'm going to like burn through the last 3 pretty quick. But, so pause the video now. All right, so you've probably unpaused it now, and here we go. Nothing really big here new. To multiply to get negative, put me on the spot here. That should be a negative 8 and a positive 6, I do declare. That'll get the job done. A negative 8 and a positive 6. Again, don't feel too bad if you're not like just banging that out mental math, you know what I mean? Like if you got to like take a minute, write down some options, that's what you got to do. Use your calculator. This one should be, I believe, a negative 8 and a positive 3. Again, it's got to be a negative 8 and a positive 3. And this one, okay, this one has a little bit of a plot twist, just a little teeny tiny new curveball thrown at you, all right? What are we adding up to here? Because we're multiplying to get negative 20, that's for sure. But the two numbers also have to add up to what? What number is there? A 1. Like, again, not a big curveball, but I mean a little bit. Like, I definitely wanted to include an example like this, number 8, where you're adding up to like 1 or -1, and you got to realize that. So considering that we now need to have these two numbers add up to +1, then we're talking about +5 and -4, because that gets you a -20 with multiplication, and that gets you a +1 when you add them up. Okay? So that's a plot twist that some people have trouble with. Another one is like problems like number 2. Sometimes people forget that, yes, you can do 1 times 8 to get 8. Like, some people forget it. Like here, like over here, same thing. My first possibility was 1 and 30. It wasn't the answer, but a lot of people forget to check that. Like 1 and 12, a lot of people forget to check that. They go right to 2 and 6 and 3 and 4, to get 12. They forget about 1 and whatever. So, that's that. That's it. So if you have any questions on your homework, don't hesitate to shoot me a message, okay? Or an email. Bye-bye.